everyone, welcome to the NPTEL course on Statistical Foundation for Big Data Analysis. I am Arindam Banerjee. I am an assistant professor at IIT Kharagpur. I'll be the instructor for this course. As the name suggests, this is a course on statistics that is relevant for big data. Now, what is big data? Big data is a term which got very popular in last 3 or 4 decades. It basically is used to denote the data set which is very big, very complex and getting generated very fast. And these three combined makes it very difficult for the classical statistical softwares and tools to analyze these kind of data. They are coming from satellite data, they are coming from social media data, they are coming from many biological network data, protein-protein interaction network, human genome data. They are coming from meteorological data for weather forecasting. They are everywhere. And due to the exponential growth in computational power in last, let's say, 2.5 decades, and as well as the internet revolution, which in turn was caused by exponential growth of computing power, made these data sets available as well as made the tools that are required for analyzing these data available to us. Now we can actually improve on the existing statistical methodologies to develop specialized tool to study these big data sets. So this course is going to be foundation for the statistical methodologies required for analyzing big data. So what are we going to learn in this course? Well, we shall start in our first module by basically giving you a detailed idea of where the big data are getting generated from, little bit in first few lectures, and then we will discuss the general framework of statistics. Then for some time we will discuss classical statistical inference, including point estimation and hypothesis testing methods. Then we'll move on to the framework of statistical learning theory. We'll spend some time on the classical supervised learning methods of linear regression and logistic regression, and then we'll get into the unsupervised learning, clustering, dimension reduction, principal component analysis, etc. And finally, at the end part of the course, we'll get into more structured data, like network data. We'll discuss random graphs, which provides a foundation for network data, various properties of random graph, and its application to several real-life situations. This is broadly going to be our coverage of this course. I mean, it's essentially going to be a statistics course. Some familiarity with probability and linear algebra will be very useful for this course. We'll try to discuss everything that is required, and we'll try to provide all the proofs of the results that are required. But it will be better if you have some prerequisites on probability and statistics and some prerequisites on linear algebra. Nevertheless, we will try to make it self-sufficient as much as possible. At the end of every week, we will get some homework assignments. These homework assignments should help you to understand the concepts well, and they will also prepare you for the exam. Exam questions, maybe you can get an idea from what I'm doing in homework assignments. A special note of caution about the content in the course. This is a course specifically meant for statistics that is relevant for big data. Now, when I was talking about big data, I said it's massive in size, massive in volume, too complex and getting generated too fast. This too complex part essentially can mean many things. It definitely means too many features, which leads us to high dimensional statistics. But these features, it's not just too many features. So if it were just too many features, the methodologies in high dimensional statistics, which is targeted towards dealing with high dimensional problems, would have been enough. But it also potentially can include situation that these features has certain structural relation amongst them. So we will also address this in terms of the network data. So overall, this is a statistics course which includes certain topics in probability, some linear algebra, some graphs as part of it. So we will discuss all the things as much rigorously as possible. Proofs will be given in the notes. You will not be tested on the rigorous proofs in either assignments or the exams, but understanding at least the proofs that I have given in the notes will be very crucial to build your concepts thoroughly. So overall, if you are taking this course, please try to understand the overall broad flow of ideas and Hopefully, you will have a nice time and learn something interesting. Thank you.